From somewhere between the orbits of Jupiter and Mars to a muddy field in Gloucestershire, these incredibly rare fragments of meteorite were found in a horseshoe print by Derek here, a retired chemist and passionate astronomer who was part of a Cambridge team given special permission to search during lockdown.
My dad died a few years ago, and at times of need I sometimes call out for his help and support. And so I just, in the middle of the field, I just shouted out, "Come on, Dad, help us find a meteorite." And within half an hour, I just come across this blue-black stone in the mud. We knew straight away that it was a meteorite, fresh meteorite. And I just couldn't believe it.
He's brought one piece to his friend David, whose unique sci-fi looking machines knock atoms off the sample so they can see what it's made of.
What's really interesting is the things that we haven't seen, because we're not seeing anything lighter than carbon, we're not seeing any lithium or beryllium or boron, and we're not seeing anything heavier than nickel. Things like gallium, arsenic, indium, tin. There's an awful lot up there, and we don't see that. I keep trying to retire. I'm winding down steadily, but when something like this comes along, it really stimulates the curiosity. And I can go back to my grandchildren and say, "I've got a bit of meteorite in the lab, we're going to look at that today. Isn't that interesting?"
Just up the road at Loughborough University, Derek's recruited more help. The machine Shaun's using is magnifying the rock 18,000 times, producing these stunning images that help him map the surface.
Looking at the shape, it's incredibly irregular. It's also incredibly fragile as well. If you were to pick it up with your hand, you could quite easily crumble in your hand. It's very, very dusty. The material itself is just loosely held together, almost like talcum powder that's slightly moist. It's basically dust from the early universe. So it's been stuck in frozen time. It's never had the opportunity to coalesce, to form a body. It's just been a loose clump in space.
Shaun's been working with materials chemist Sandie, another one of Derek's friends.
So the minerals we're finding in the meteorite are similar to those that we find on Earth, but a little bit different. So that tells us that the chemistry out there in outer space is a bit different to what we see on terrestrial Earth.
Next, the Cambridge teams offered samples to scientists in the US and Germany. These tests could help answer a key question. Did some of the ingredients that triggered life on Earth arrive on rocks from outer space? Richard Westcott, BBC News, Loughborough.